Okay, so here we have a theorem. So it says that if you have that the derivative of a function f is equal to 0 for all points in an interval a to b, then f is constant on that interval. And so this makes sense because we know that if we have a function that has a derivative of 0, that it has to have a horizontal tangent. And if a function has a horizontal tangent at every single point in an interval, it makes sense that it would have to be a straight line or a horizontal line, right? But our intuition there is correct, but how do we know mathematically that it happens at every single point, that f is equal to the same exact constant, right? So we can go ahead and prove this using the mean value theorem. And so what we want to do when we're thinking about proving this, so we want to apply the mean value theorem. And so the first thing we need to do is check that this function satisfies the requirements or the hypotheses of the mean value theorem. Remember, there were two of them. So that f is continuous on the closed interval a to b and differentiable on the open interval a to b. And so when we're looking at this, notice that we're given that f prime is equal to 0 on an entire interval, and if it's equal to 0, then it must exist there, right? So f prime exists on the open interval a to b, right? And since f is differentiable at every point, or maybe I'll state that as well. F prime exists on the open interval a to b, which means f is differentiable on the open interval a to b. And then we also know that at every point where f is differentiable, it has to be continuous, right? So also f is continuous on AB because it has to be continuous at every point where it is differentiable. Now, this is not quite what we need to apply the mean value theorem. So remember that when we need continuity on the closed interval a to b. And so we do have to be careful that we have the exact requirements needed before we apply the theorem. And so what we can do is we can instead pick 2 points inside of the interval, so that lie inside of the interval, and then we will have continuity on that closed interval because we know that we have continuity on a larger interval containing it. So what we will do is let x1 and x2 be points in the interval AB, and just assume we know that one has to be less than the other if they're not equal, so we'll just say that x1 is less than x2. Okay, then we can say f is continuous on the closed interval from x1 to x2 because it's continuous on the larger interval AB, which contains this one, the x1, x2. And also f is differentiable on the open interval x1 to x2 because it's differentiable on the larger interval a to b. Okay, now we can apply the mean value theorem So by the mean value theorem, there exists a point C in the interval x1 to x2 such that we have that f prime of C is equal to f of x2 minus f of x1 over x2 minus x1. Okay, now what I can do is multiply both sides by this denominator, and I will get this in the form x2 minus x1 times f prime of C equals this other stuff. And then what I can do is use the fact that f prime of C, since it lies in the interval, is equal to 0, right? So that we get x2 minus x1 times 0 equals this other side, which means this whole left-hand side is equal to 0, and I can pull that f of x1 to the other side, and I get that f of x1 is equal to f of x2. Okay. And then we say, oh, well, you know, x1 and x2 could be any 2 points in the interval a to b. Any 2 points in the interval a to b, so we know that f is or has the same value at every point. Every point in AB, which is exactly what we were trying to show. Now, unfortunately, I've run out of room, so what I'm going to do is write something else up at the top. Okay, so this was our proof of this fact, so that's done now. And then something that we can conclude from this, and I won't go through why this is the case, but we can talk about it in class. And so this is what is called a corollary, and it is just a smaller theorem that comes as a result of a bigger one. And so instead of being its own result because it's so related to a larger theorem, we call it a corollary. And so this is to say that if you have two functions and you know that their derivatives are equal, they're equal everywhere, then the first function, f of x, is, or we could say that then f of x and g of x differ by a constant. Okay, and then it's not immediately obvious that this would be a corollary, so you do have to do some justification of this, but it's not too difficult, and we'll talk about it. Okay, so don't forget to complete the comprehension check question.